Hello and welcome to our lesson on redox reactions. The first half of this lesson is for everyone. The second half of this lesson goes on to higher content only. So in some reactions, not in all, substances can be oxidized or they can be reduced. Oxidation is when a substance gains oxygen, and reduction is when a substance loses oxygen. Let's consider the displacement reaction below. So iron oxide plus zinc makes iron plus zinc oxide. It's a displacement reaction because the more reactive zinc metal displaces the iron and takes the oxygen for itself. What is being oxidized here? Well, oxidation means gaining oxygen. What didn't have oxygen at the beginning of the reaction and by the end of the reaction does? The answer is zinc. The answer is zinc, not zinc oxide, because zinc oxide is not being oxidized. It's already got oxygen. It's the zinc itself that is gaining the oxygen to become zinc oxide. So be careful. And what is being reduced? Well, reduction is losing oxygen. What had oxygen at the beginning of the reaction and by the end of the reaction doesn't? Well, it's the iron oxide. Again, it's iron oxide that is losing oxygen. The iron doesn't have any oxygen, so it's the iron oxide that is being reduced, not the iron. In redox reactions, so redox stands for reduction oxidation reactions, and they always go in pairs because if something is losing oxygen, then the other thing is gaining oxygen. So redox reactions. We can also talk about agents. Now, this is where people typically get a little bit confused, so it's worth slowing down and paying attention. The oxidizing agent is the substance that is giving up its oxygen and allows the oxidation to take place. Okay, so if we look at our equation again, what's the oxidizing agent? What is giving up oxygen and allowing this process to take place? What's giving up oxygen? Well, it's the iron oxide. So the iron oxide is the oxidizing agent. It's the one that is responsible for the oxidation. We can also talk about reducing agents, and the reducing agent takes the oxygen and allows the reduction to take place. So it's the one that is taking the oxygen. So again, if we look at our reaction, what is the reducing agent? What is taking the oxygen? Then it's the zinc. The zinc is allowing the reduction to take place because it is taking the oxygen away from the iron oxide. Okay, here's a question for you to have a go at. I suggest you pause the video and have a go yourself. And notice I've written the core concepts we've just been talking about down the right-hand side to remind you. Okay, let's look at this reaction. We've got tin oxide plus magnesium, and it's a displacement reaction making tin plus magnesium oxide. So what has been reduced? Well, reduction is losing oxygen. So what has lost oxygen? That would be the tin oxide. What has been oxidized? Well, oxidation is gaining oxygen, so that would be the magnesium. What is the oxidizing agent? Well, that's the one that gives up its oxygen, so that's the tin oxide again. And what's the reducing agent? Well, that's the one that takes the oxygen, and so that's the magnesium. Okay, so pause the video again and have a go at this one. A little bit more challenging as we've not got the words, we've just got the symbols, but it's the same concept. Okay, so what has been reduced here? Well, it would be the CuO, that's the copper oxide. Okay, what's been oxidized? What has gained oxygen? That would be the lithium, Li. What is the oxidizing agent? So that is giving up oxygen. Well, again, that's the copper oxide. And what's the reducing agent? Well, that is the lithium. Okay, the rest of this video is for higher tier only. So if you're foundation, you can turn off and finish. Thank you very much. So redox reactions also show the transfer of electrons. Let's consider this equation and let's look at zinc. So this is the same reactions we had previously, but let's look at this zinc. And we're going to look at the electrons. So here we have zinc just on its own, so it would be an atom. So it looks something like this, Zn. By the time we've got over here, it's part of a compound and it would have lost electrons, so it would bond. And so actually this is a zinc ion and it would have a 2+ charge. So how does it get from the zinc atom to a zinc ion with a 2+ charge? Well, I would have to take away 2 negative electrons. And I would write like this, -2 E minus. So E minus is the symbol for electrons because electrons are always negative. And I'm taking away 2 to get that 2+ charge. Remember, if I'm taking away negatives, I'm becoming more positive. And this is known as a half equation. So oxidation is not only is gaining oxygen, but it can also be losing electrons. And the way to remember this is oil. Oxidation is loss of electrons. Okay, so it's a half equation because there's another side to the equation. Let's look at this equation again, but this time let's consider the iron. So the iron at the beginning as a reactant starts off as part of the compound. It's an ionic compound, it's going to be an ion, it's going to have a charge, and iron has a +2 charge. By the product side, by the end of the reaction here, this is now iron on its own. It's an atom again, Fe. So how does it go from a 2+ charge ion to an atom again? Does it lose or does it gain electrons? Well, this is where we often get confused. We're positive and we want to say, well, we're going to lose electrons. Well, if we lose electrons, we're going to become even more positive, aren't we? So we're actually gaining 2 electrons. And we would write that like this, +2 E minus. So the E minus again is electrons and I'm adding 2. And this is the other side of the equation and this is the other half equation. So reduction is also gaining electrons and we can remember that by RIG. Reduction is gain. So here's that core concept, oil rig. Oxidation is loss of electrons, reduction is gain of electrons. Now, in all honesty, I cannot do an exam question without writing oil rig down. I get confused, I need to double check myself. And if you're just scribbling down oil rig, so be it. Do whatever you do in order to help yourself. So let's look at this worked example. It says work out which element has been reduced in the following equation. Cu2 plus Mg makes Cu plus Mg2 plus. So the first thing I'm going to want to do is I'm going to want to think about my core concept, oil rig. So I've got that there for later. Second of all, I need to work out whether each element has lost electrons or gained electrons. And the easiest way to do that is to write the half equations. So let's look at the copper first. Copper is going from an ion, 2+, to an atom, Cu. And so I am going to add 2 electrons to become a copper atom. Magnesium is going from an atom to an ion. So it's losing 2 electrons to become positively charged. And I would be so very careful and talk my way through those. Am I right? Have I got that the right way around? How do I do that? It's so easy to take away an electron rather than add an electron. And of course, that then changes whether you're writing oil or rig, reduction or oxidation. And given that's the question, it's very easy to get it wrong. So now I've seen those half equations and I'm confident that they're correct. I can look at my question. It says reduced, which is the rig side of things. Reduction is gain of electrons. So if I'm reducing, I'm gaining electrons. Which of those half equations is gain electrons? It's the copper. and so the copper has been reduced. So it's quite a lengthy process for what looks initially like a very short question, but take your time and make sure that those half equations are the right way around, otherwise you are going to get the whole thing wrong. Okay, so it's your turn. I've left a core concept up for you. Pause the video and have a go for yourself. Okay, so the first thing I'm going to do then is those half equations. I've got a lead ion becoming a lead atom, and I'm going to add 2 electrons. And I've got zinc atoms becoming zinc ions, so I'm going to minus 2 electrons there. Okay, so I'm thinking oil rig. The question is asking me about reduction, so that's rig, in which case it's the lead that has been reduced. Okay, so pause the video and have a go at this, particularly if you got the last one wrong. Just pay attention to those half equations. Okay, so first of all, then I'm going to have a go at those half equations. Now, for some reason, every question I've given you has had a 2+. That's just a coincidence. It could easily be an ion with a 1+, or an ion with a 2+ or a 3+. So it just so happens that all the questions I've given you is a 2+. Sorry about that. Anyway, so I've got a tin ion with a 2+ charge, and I'm making a tin atom. So I've got to plus 2 electrons to get there. And then I've got magnesium atoms become magnesium ions, and so I'm minusing 2 electrons there. The question's asking me about which element has been oxidized, so that's the oil part, so oxidation is loss, and so that's the magnesium that's been oxidized. Okay, last question for this lesson. Challenge for you. It says identify the oxidizing agent in this reaction. Okay, just pause the video and have a go. So again, I'm going to start with the half equations to give myself more information. I've got my zinc atom becoming zinc ion by taking away 2 negative electrons. And I've got my hydrogen ion becoming a hydrogen 2. So it's a molecule of hydrogen, because hydrogen is always diatomic, which is why I've got 2 hydrogen ions at the beginning there to balance that out. And I'm adding 2 negative electrons there. Okay, so it's asking about an oxidizing agent. So oxidation is loss. Okay, so let me think about this. So zinc is losing electrons, but the oxidizing agent is the one that's giving up the oxygen. So hydrogen is causing the oxidation, and therefore it's the hydrogen ion which is the oxidizing agent. Okay, so that is a little bit trickier because it's not oxidation is loss. Okay, so it's zinc. You're thinking, okay, oxidation is loss. Zinc is losing electrons. What is causing the zinc to lose the electrons? Well, it's the hydrogen ion, which is taking away those ions from the zinc. That's the end of today's lesson, guys. Thank you.